Good morning. Today I'll see bilinear transformation. There is a problem. Convert analog filter with system function h of s is equal to 5 by s plus 3 into s plus 5 into a digital IIR, that is impulse invariant response filter using bilinear transformation. Here this question they have mentioned assumed t is equal to 1. So we can assume t is equal to 1. This is very simple problem. So h of z is equal to, we can write that is h of z at s is equal to 2 by t 1 minus z power minus 1 divided by 1 plus z power minus 1. This is what we are going to substitute for s. Therefore we can write h of z which is equal to, so what is given here, 5 divided by, in the question they have mentioned 5 divided by, so here we have s. So instead of s what we have to write is 2 divided by, and we know that t is equal to 1. So we can directly substitute 1 into 1 minus z inverse divided by 1 plus z inverse plus, here it is given 3 into, again here we have s. So the s should be replaced by 2 by t. T is equal to 1 into 1 minus z inverse by 1 plus z inverse into plus, here we have 5, here we have 3, and here we have 5. Therefore which is equal to, that's it, we have to solve this. So 5 divided by 2 into, here we have 1 minus z inverse plus 3 into, let us take LCM for this, divided by 1 plus z inverse into, and here we have 2 into 1 minus z inverse plus 5 into 1 plus z inverse divided by 1 plus z inverse. Therefore which is equal to, we can write this as 5 into, let us take this 1 plus z inverse into 1 plus z inverse in the numerator. So that will become 1 plus z inverse the whole square. That be divided by, now multiply this, 2 minus 2z inverse plus 3z inverse into, and here we have 2 minus 2z inverse plus 5 z inverse. Therefore we can write this as h of z is equal to, now let us continue here. So h of z is equal to 5 into 1 plus z inverse the whole square divided by, and here what is present here, 2 plus 3. So 5 plus, here we have 3 z inverse, and here we have only 2 minus 2 z inverse. So z inverse into, here we have 7 plus 3 z inverse. Now let us continue. So which is equal to 5 into 1 plus z minus 1 the whole square divided by, now let us write this as 35 plus, let us multiply this, plus 22 z inverse plus 3 z power minus 2. Let us write this directly, because after multiplying this we will get this, which is equal to 5 into, here we have a plus b whole square. Therefore we can write this as 5 plus 5 z power minus 2 plus 10 z power minus 1 the whole divided by 35 plus 22 z inverse plus 3 z power minus 2. This is our h of z value. That's it. Now let us move on to the next problem. I hope you understand. Actually this is the given question, 5 by s plus 3 into s plus 5, and what we have to do is, instead of z we have to substitute 2 by t into 1 minus z inverse by 1 plus z inverse, because here on the question they have mentioned bilinear transformation, and also we have assumed t is equal to 1. Now substitute here, instead of t we can replace this t as 1. Now we can substitute 5 by, now multiply this and take this 1 plus z inverse to the numerator, so that will become 1 plus z inverse minus the whole square. Now after this you just multiply this, so 35 plus, so after completing this you will get the final answer. That's it. This is very simple method, bilinear transformation, it is very simple. Now let us move on to the next problem. Just a minute. This is a problem. Convert analog filter with system function h of s is equal to s plus 0.4 divided by s plus 0.4 the whole square plus 16 into a digital IAF filter using bilinear transformation, and here also we have to assume t is equal to 1. The same way, we know that h of s is equal to, what is given here, h of z, that is h of z is equal to h of z at s is equal to, we know that 2 by t into 1 minus z inverse divided by 1 plus z inverse. Therefore, we can write this as h of z, which is equal to, and here we have s plus 0.4. Now we have to replace this every s by using this 2 by t. So we can write this as 2 by t into 1 minus z inverse divided by 1 plus z inverse plus 0.4, because s plus 0.4 the whole divided by, here we have s plus 0.4 square. So what is s here? That is 2 by t into 1 minus z inverse divided by 1 plus z inverse plus, that is s plus 0.4 square. So plus 0.4 the whole square plus given as 16, and we know that t is equal to 1. So what we can do is, here we have, let us take this as a plus b whole square. So 2 by t, that is a will be equal to 2 by t into 1 minus z inverse divided by 1 plus z inverse, and let us take b is equal to 0.4. Now let us expand this in the form of a plus b the whole square. Therefore we can write this as h of z, which is equal to 2 into, in the numerator, 1 minus z inverse plus 0.4 into 1 plus z inverse the whole divided by, here we have 1 plus z inverse the whole divided by, let us expand this equation. So 2 by t into 1 minus z inverse divided by 1 plus z inverse the whole square plus 0.4 the whole square plus 2 into 2 by t into 1 minus z inverse divided by 1 plus z inverse plus 16. Therefore, we can write this as, let us continue here. h of z is equal to, so let us continue in this, 2 into 1 minus z power minus 1 plus 0.4 into 1 plus z power minus 1. Here we divided by 4 into, since we know that t is equal to 1 here, since t is equal to 1 here, so we can write this as 4 into 1 minus z inverse divided by 1 plus z inverse the whole square plus 4 square is 0.16 plus, and multiply this, here we have left 0.4, so that is 0.8 into, here we have 2 into 1 minus z inverse divided by 1 plus z inverse plus 16. Therefore, we can write this as, which is equal to 2 into 1 minus z inverse plus 0.4, here we have 1 plus z inverse, 0.4 into 1 plus z inverse divided by 1 plus z inverse the whole divided by, and here we have 4 into, let us write this as 1 minus z inverse the whole square divided by 1 plus z inverse the whole square plus 0.16, here it is visible, plus 1.6 into 1 minus z inverse divided by 1 plus z inverse plus 16. Therefore, we can write this as, which is equal to 2 minus 2 z inverse plus 0.4 plus 0.4 z inverse the whole divided by, here we have 1 plus z inverse the whole divided by, let us take LCM. Therefore, 4 into 1 minus z power minus 1 the whole square plus 0.16 into 1 plus z inverse the whole square plus 1.6 into 1 minus z inverse into 1 plus z inverse plus 16 into 1 plus z inverse the whole square the whole divided by 1 plus z inverse the whole square. Now let us cancel this so that we can write, which is equal to, now let us multiply this and we can write, let us take this to the numerator. So after taking this to the numerator and after processing this multiplication and everything, you'll get the answer. See, after doing multiplication and after doing every process, so that we will get here 2 minus 2 z power minus 1 plus 0.4 plus 0.4 z inverse plus 2 plus, because we are going to take this to the numerator, so after multiplying with it we will get in the numerator, and in the denominator after multiplication we will get this. So finally we will get the answer as h of z will be equal to, this is the final answer. This is how you have to perform this bilinear transformation. So this is very simple, as I said before. What we have to do is just we have to replace this s as s is equal to 2 by t into 1 minus z inverse by 1 plus z inverse. Then we have to substitute and we have to find the answer. That's it. If we have t is equal to 1, then we have to substitute t is equal to 1. Or if we have values like t is equal to 0.1, 0.2, 0.3, whatever it may be, so we have to substitute that values here. For t, we have to replace that by that value. So that's it. You can meet in the next video. Thank you.